Welcome back. Here's the situation. We have a front end that's already nearly complete, and we're being asked to make a back-end API, which will let this mission control dashboard schedule missions and view historical and upcoming data as well. Our first task will be to dive in and understand how our API will be used by this client. And from there, we'll work together with the front end to prepare our project for launch. Let's dive in. In our NASA project, our client we've seen is a React application. Now, this isn't a React course, so we're not going to cover React from the very beginning. But let's go over what our front end is doing conceptually and see how we can integrate the endpoints that we'll be building into this code to hook up all the functionality that our dashboard allows our users to perform. I promise this video is as deep as we'll get into React in this entire course. Nothing too crazy, but also it might be an interesting overview if you've never used React before, or even if you have. Whichever group you're part of, I'm sure you're going to learn something. We're using ROS for our sci-fi components and React, as we've just discussed. We have React scripts from Create React App, which helps us build and start our React project without having to worry about any of those complicated front-end build systems. The other two dependencies we have here are React Router DOM, which allows our front end to have routes of its own. For example, for the /upcoming page, which lists upcoming launches, versus the /launch page for creating a new launch. We'll see that in just a second. And React DOM allows our React code to make use of the document object model, because our application is a web application. And the DOM is the object the browser uses to store the current page that you're viewing. There's other variants of React, like React Native, which allow us to build mobile applications, and that would use a different package to render your React application and all of its components. All right, so in our source folder, we have some files, and in public, we have some assets, some background images, and sounds as well. For our user interface, we have a favicon and this index.html, which will contain our React application. So the HTML here is all standard. It includes things like the description of the page, the favicon, and if we scroll down, we have our title, we have some style sheets, and then we have this root element, which is where our React application will get loaded. So all of these files in the public folder are those that are going to be served to the browser directly, without any fancy processing by the React framework. And the way this root element gets populated is in this index.js, where we use that React DOM package to render this app React component on the HTML element with the root ID. That's right, the one we just saw. And this app component here uses a React syntax called JSX, which kind of looks like HTML. So React code knows how to render these JSX components based on, in the app case, this app.js that we have here. And this is the main entry point of our application, where we use this ROS framework to set up our user interface theme, the sounds that we'll be using, and the ROS framework itself, which provides us all these nice animations for when we're working hard and navigating through that NASA launch system. We can think of all of these components that we have here as custom HTML elements that React knows how to render. We can use them for visual components, but also for functionality like routing. This router component comes from our React Router DOM dependency to allow us to navigate to different pages in our browser. And the component that handles our router is this app layout page, which comes from our import over here. And our theme and sounds come from this settings module in settings.js, where we have the images and sound data telling ROS where to find our sounds files, and also our theme, which has things like colors and font information for our application. Now, what about that app layout component? Now we're getting to what's important to us as backend developers. In our pages folder, we have all of the different pages of our front-end application. So we have this root app layout component, and then we have a history page, a launch page, and an upcoming page. If we look in our root app layout and scroll down, we have some custom styles for this page, but our component definition starts here, where we set up some animations for when we navigate from one page to another. We have our sounds. These functions will play the corresponding sound. And going a little bit further, we have all of the different React components that make up our app layout and allow us to show those individual pages. This should seem familiar. We have a header, which allows us to navigate from page to page and has our fancy logo. And we have a frame, this box that contains the route that we're currently browsing. So it could be the launch route over here. And we also have this launch route being rendered when we navigate to just the route for when we first load our page without any of our specific route paths. So that handles the launch. And then we also have the upcoming page and our history page. That's the overall structure of this app layout component. There's a lot going on here, so let's break it down. At the top here, we can see a header and this centered component. These are components that we've defined in our components folder here that just handle with working with centered content. And we have one for clickable objects on our page, where we play this click sound when that click happens on click. And we have our footer with just some text in a paragraph that's also centered, and a header, which contains, if we scroll down past these styles, our logos, and then a series of these clickable links, which allow us to navigate to each of our pages. So /launch over here, upcoming, and so on. One of the main ideas behind React is building up these larger components using the tiniest little components, like, for example, this base HTML italic tag, and layering them on top of each other to build more complex functionality. So our components folder here contains some of these components that we've built up that we might want to reuse in our different pages. Now, the other most important piece here is the hooks. If we go to our app-layout.js and we scroll just above our return statement, where we return all of these components, we'll see a couple of these use functions, like use launches and use planets. These are hooks, which are React's way of responding to events that occur in your application and managing the resulting state of your application. With hooks, you take the state that would live in your React components, these things like the header and the footer, or any buttons or forms that your application is composed of, and you move this state into these hooks instead, which simplify how you pass this state, like the list of planets, around between your different components, which we can see, for example, the list of planets being passed into our launch page because they're required for that dropdown. So you capture this state in the hooks, and you also save React from re-rendering your application needlessly, because React can keep track of exactly what state has changed versus what state hasn't changed, and only render the things that have changed. Let's look at this planets example. We can see planets is set to this usePlanets function that comes from our usePlanets.js. And all this is doing is returning this planets variable, which we set up here using this destructuring syntax. So our useState hook, or this useState function coming from React, returns two things. It returns this planets variable, which starts as being an empty array. This is the default value, and is then populated by making this HTTP request to get the planets from our API. And once we've fetched our planets, we can call this savePlanets function, which React has made available for us, to set the planets variable to the response of our HTTP request. And now, because we've used this function, this hook, React knows to keep track of this state in the most efficient possible way. And this useEffect hook, again coming from React, is a function that will always call this getPlanets function when the application first loads, because our list of planets is required right away. Just a really quick overview here. But that's pretty much the extent of React that you need to know for now. The same thing applies to our launches. If we scroll down, it might seem a lot more complicated, but it's the same patterns that we saw with the planets. We're managing the state of our launches array, as well as this additional variable for whether the launch is currently pending or not, which represents when the server is still processing our request. The only new hook that we have is this useCallback, which is the React way of saving our application from needlessly recomputing whatever's in this callback function that we pass into it. In this case, from getting those launches from our HTTP endpoint and saving them to our launches array. We still have this useEffect that will always call the getLaunches function when the application first loads. And then we have a few functions for submitting the launch and aborting the launch when the user presses that X symbol. And finally, we return these functions and the data they manage from our useLaunches hook so that we can make use of them in our app layout. We take these variables and these functions and pass them into whichever components they're being used in. So we can see the launch page makes use of the planet's data and the submit launch function, as well as whether the launch is currently pending or not, probably for some loading animation or some loading state. To wrap up with our hooks, all of these hooks are really just making sure that our application state is saved and any calculations or API requests needed for that state are only performed when the user performs some action that will cause an update. For example, our launches data won't be reloaded every time we switch pages because nothing has changed. Hooks are great for making our React applications more efficient and minimizing the amount of requests that our API needs to handle, which speeds everything up. Everybody wins. All right, so how do we make these requests from our front end? Well, these HTTP functions are being imported from this requests.js file right over here. But that's where we come in, because these functions haven't been implemented yet. We need an API which defines what these requests will look like. We just know that we're going to have at least 4 basic requests to get the list of planets and make it available as a JavaScript object, to get the list of launches, submit a new launch for our mission to one of the Kepler exoplanets, and to abort or delete a launch with a given ID. We have some work cut out for us. Let's get to it and start working on that Mission Control API. I'll see you in the next video.